Hello, today I would like to show you a couple of tools that are in the JDK that perhaps you didn't know about. I certainly didn't know about it, at least until a couple of days ago, or about a week or two ago, and I think it's interesting. These two tools are used generally to analyze memory dumps that are created when the VM runs out of memory. But they can be used to analyze the VM's memory at any point, really, when you decide that you want to see what's going on in there. So the first one that I want to show you is jmap. Here's the jmap executable, and then what we're going to do is once we have a memory dump generated by jmap, we're going to analyze it or take a look at it through jhat, and that is up here. So we're going to use these at the command line, and I've already put the bin folder on my path variable for the system and made a nice new folder so that I can see the results that come out of this run. Now if you go just jmap, you're going to get the man page for jmap, and as you can see, all jmap really requires is a process ID in order to get the information out of a VM that's running on your machine. Now this can also be done remotely, and so you see support for that and various options included, but we're just going to show you a very basic operation of this tool today. So first thing you need to do is have your program in a state that's ready to be read. So generally this is going to be done by setting a debug point and just running it up to that debug point and then running the jmap tool. So we're going to run our program here, and obviously this is just a very trivial test application. So actually not run as, but debug as, because you want it to stop on the debug point to give you enough time to start the tool and know what's actually going on inside the machine in terms of where it is in the code. So we'll run as, and we don't want to change the view. It's sitting at the debug point. Now this next part takes a little bit of guesswork. You have to come in using your task manager and guess pretty much what process the Java running is taking. Now this is pretty much surely Eclipse. I've already run it at least once today, and it wouldn't be on the apps subset anyway. It would be under the running processes. So here we go. There's only really one Java virtual machine running right now, and it is on process ID 6564. So we just hop over here, we go jmap 6564, and actually, well, so it's 6564. This is actually just going to show you a kind of dynamic status of some sort here. It's not actually going to show you or start the dump process. So this is helpful information probably, but it's not what we want. What we want is jmap and then -dump, and then name the file that you want it to be stored in. File equals, how about dump1.hprof. hprof is just the format that the file will take, and then we tell it the PID again. Just take a peek, remember which one this was. It was 6564, and it tells you that the file exists. Of course it exists because I previously did this. Let's say dump2.hprof. Alright, so here you see the dump that I created just before this video and this current dump. And you're looking at the file, you say, okay, 3 megs of whatever's in there. So in order to take a look at it, you need to open it up with the jhat tool. So jhat, and then dump 2, go here, and then you'll see that it's set up a web server. This web server is like real old school. It's in HTML, and it's very, very basic looking, but you don't need it to be pretty. You just need it to show you what you need to know. So it's going to be at localhost 7000, and as you can see, we have a couple of links here. There's a heap histogram, and this should really show you how much is going on in the background with the virtual machine, because there's all kinds of classes loaded here. The total size of all arrays of integers, for example, is something like 2,300,000, and this is just there in the background for having started up the virtual machine. So all these things are here basically because there's a virtual machine there. So knowing that there's a lot of noise there, the creators of this tool have set up the option to look at just the classes that are loaded from your program specifically. So instance counts, show instance counts for all classes excluding the platform. And now you can see that there are 100 instances of my test class. And this makes sense because if you look at it, all that this test class does is instantiates a collection of test class and then adds 100 instances of that test class to the collection. And then when you get to this debug, it just holds there and waits for you to come and see those objects. Now it's worth pointing out that this memory dump will show you things that haven't been garbage collected yet. So as you can see here, there's now a subroutine, or a function that executes a very similar action here, and it then goes and creates the same kind of a collection again in the main routine. And if I set a debug point here and then I run, well, actually, you know what, let's stop the execution of the original one, and then we will start the execution of this one. So what do you think is going to happen here? I guess if you were expecting, from a standard Java developer's mindset, you would break here and then really only expect to see these classes here, because anything that happened in this method should be totally gone. It's not accessible to you anymore. But let's see what happens. So debug as Java application. Now we go in and we look for our new PID. So it is 11,568. So we'll close the web server here. We'll go do the same thing we did before, only with 11,568. Wow, I can type. Oh, and of course we need to update the file name. So now we're going to take a look at what's in dump 3. So we'll just reload the main URL here. Now we see there are instances of test class 2. And keep in mind that we broke here. So in standard Java, frame of mind, anything that really happened in the local variables for do something here shouldn't exist. And yet, here we are looking at instances of test class 2. Now we can ask this analysis to show us the counts again, and we'll see that all 50 instances of those are right there. So there is something that you can do in order to stop just dead and unimportant, uncollected objects from being reported here, and it's called garbage collect, and system.gc will usually do the trick. So this is something that you'll generally want to do if you want to get an accurate idea of what's going on in your VM when you're taking a dump like this. So thanks for watching, and I hope you continue to watch my videos. Thank you.